Hey everyone, it's Orkan. Welcome to my channel. Today we are going to solve LeetCode 142 linked list cycle 2 problem. So the problem statement is that we are given a head of the linked list and we need to return the node where the cycle begins. If there is no cycle, we should return null. So for example, let's take this example. So in this case, the cycle starts at index of 1, so we are returning position of 1, so that's why we are returning 1. In this case, it's just the cycle, so we are returning 0. Let's take another example. Let's say that we have nodes here, and let's say at this point it starts to go to cycle, right? It starts to go to cycle, and in our case we need to return particularly this node. So if we they may meet somewhere else, let's say that we may find that that they meet, for example, in some other location, this node, that because in this case we are going to use fast and slow pointer approach. So let's say that they meet here, fast and slow pointers. So but we need to return where the cycle starts, so which means that in this case index of 2, so we need to return. Okay, that's the problem statement. Let's see how we are going to solve this problem. All right, let's start. Let's take this example. Let's say we have 3 nodes here, and that is pointing, and also here it goes into circle. So in the circle, let's say we have 3-4 nodes, and this is our circle. So this is our linked list, and we need to return this value, this node, starting position. So how we are going to solve this problem? Usually in this kind of problems, when we need to find the circle, we are applying the approach that is called the slow or fast pointer, or some people call it tortoise and hare. So I think that it would be easier just call it fast and slow. So fast and slow. So what's the idea behind it? The idea is that so we are moving the slow 1 step at the time, and the fast we are moving 2 steps at the time. And as we are moving, so if there is a circle, if there is a null, so first we are going through this linked list, and if there is a null, we are returning false because there is no circle. But if it's not null, so it means that there is a circle. And if there is a circle, so these two are gonna meet. So let's say this one is moving 1 step at the time, and this one is moving 2 steps at the time. So after certain iterations, they are gonna meet at the certain node. So that's how we are finding that if there is a circle or not. So let's say that they met at this circle. So let's say that we are applying this strategy, slow and the fast pointers, and they are going in the circles. And they are going in the circles, so they meet, so they equal to each other here. And that's how we'll find that there is a circle. But what's the starting point? For the starting point, let's mark this distance as, let's say, I don't know, like something like as m, and let's mark this distance from the beginning to the beginning of the circle. Let's mark it as m, and let's mark this distance from here. Let's say that to here. Let's mark this distance as n. So from the beginning to the point where they meet. So from the beginning of the circle to the point where these two meet, fast and slow pointers, let's name it as n, let's say. And the distance from here, from this node where they meet to the to the again beginning of the circle is, let's call this distance as k. Okay, the way we solve this problem, first we are applying first and slow approach, and we are finding whenever they are equal to each other. So at this point they are equal to each other, fast is equals to slow, and we know that there is a circle. So at this point then we find out, okay, there is a circle, but we need to return this position. So the distance from then what we do then, the next step, we are starting again from the head for the slow, and the fast pointer we are moving one step at a time. The point where they meet is the starting point. So basically we are moving f one step, and s equals to head, and we are moving one step at the time. And for the fast, so from this distance we are also moving one step at the time, and whenever they are equal, f is equal to s. That is the point where they meet. That's the point, this point where there is a position where they meet, and we are returning that. Starting point, let's say starting. But the question arises, how we can be sure that they are going to meet. So the distance from here, from their meeting point to the beginning of the circle, and from the head to the beginning of the circle is equal. So actually there is a mathematical proof for that. So we can prove actually that they are equal. I'm going to make a separate video on it. But so if we write down this equation, so at the end we have that the m is equals to k. So basically the steps that these are making from, so if we are moving s to the beginning, so it makes the m steps, and this fast also makes the k steps, and the point that they are meet, so this distance and this distance, basically they are equal to each other. That's how we are, how we are approaching to solve this problem. Again, the first thing that we are doing, we are initiating two variables, fast and slow. We are proving that, okay, there is a circle. Let's say that they meet here or whatever, and then we are moving setting the slow pointer to the head, and moving and the fast pointer. So from that step on, we are moving both of them one step at a time, and the point where they meet is the starting point of our linked list. All right, let's go to the solution part. All right, let's start. So first thing that we are gonna do, we are gonna check that if the head is equals to null, or if the head next equals to null, so which means that if there is no element, if there is no node, or if there is one node, so there is no circle, so we can return null. So if not, then we are initializing two nodes. List node 1, let's call it slow, which points to the head, and the same is the list node fast, which is also pointing to the head. And we are gonna move the slow 1 point, so one step, and the fast is gonna move fast next, so it moves two steps at a time. So we go to the loop, and to the while loop, and so we check that if while fast is not equal to null, and the whatever comes after the fast, if the fast next is not equals to null, then we are what we do, we are, so meanwhile we are checking that the if fast, if slow equals to fast, then it means that if slow equals to fast, then it means that there is a circle, and we are just breaking that. So let's break this circle, break this loop. So if not, then we are slow, we are moving, slow equals to slow, next, and fast equals to fast, next. So 2 steps at the time. Okay. 2 steps at the time. Okay, once we exit this loop, we have either circle or we don't. So if we have a circle, means that one of these, so we can actually copy paste this one. So which means that the one of these conditions should be true. So if fast equals to null, or fast next equals to null, then we don't have a circle. So in that case, we can return null right away because there is no circle. But if they are not, which means that there is a circle, and we find the circle. So in that case, we are again setting slow to the head of the list, and what we do, we go to the while loop one more time, and this time we say, okay, till slow, if go through the loop till slow is not equal to fast. Until they are not equal, just slow go 1 step at a time, and the same fast. Fast is next, so move them 1 step at a time, both of them, and that's it. After that, just return either slow or fast. So because now this is the starting point of our loop. Okay, let's run this. Oh, great! It works as expected in the first try. So let's go over it one more time. So what we do, we are checking our head if there is only one, if there is no node, or if there is only one node. In that case, we return null right away because it's impossible to have circle. Then we are initializing 2 fast and slow pointers. We are moving slow pointer 1 step at a time and the fast 2 step at a time, and we are moving till we reach either end of them, till we reach the end of the node, list node, a linked list, and or we are till the slow equals to fast, which means that there is a circle. If they are equal, then we are breaking. So once we exit this loop, while loop, we are checking that if there is a circle or not. So how we can check it? By checking the fast. If the fast or fast next equals to null, which means that there is null and there is no circle. So we are returning null. If not, then we are initializing moving slow to the beginning of the LinkedList, and we are moving slow and fast, one step at a time. As I said, distance from the beginning of the, as I already explained in our step by step part. So distance between the beginning of the linked list to the beginning of the circle, let's call it M, and from the point where these two fast and slow met, from that point to the beginning of the circle is the same. So we are moving them one step at a time, and once they meet, that is the node where the circle starts. All right, that's it for today. I hope you like my content. If you like it, please hit the like button and subscribe my channel. See you next time. Bye.